Welcome, everybody. We get to talk about database DevOps with containers. Here's the part where I tell you I'm definitely going to post this on my blog tonight. You're going to look at my blog tomorrow, next week, next month. In about 3 months, you're going to be tired of waiting. You're going to email me. In about 6 months, I'm going to reply and say, no, I'm definitely going to post this on my blog tonight. And I'll never post it ever. Which is why you can go to my blog right now. You can go to robrich.org, click here on presentations, and scroll down this list to database DevOps with containers. You can look at the slides right here that we're about to see and dig into the code that we're about to look at as well. Feel free to get ahead, heckle me about the slides I haven't said yet. You know, this will be a lot of fun. While you're here, click on About Me, and here's some of the things that I've done. I'm a Microsoft MVP. I'm a friend of Redgate. AZ GiveCamp is really cool. AZ GiveCamp brings volunteer developers together with charities who otherwise couldn't afford software services. We start Friday after work building them software. Sunday afternoon, we deliver completed software back to the charities. Sleep is optional, caffeine provided. It's really fun. We're ramping up to our next event in March. And so go to meetup.com/AZGiveCamp and learn more about AZ GiveCamp. SQL Server Source Control Basics, I had a lot of fun with that book. We'll dig into a little bit of things that we talked about there today. Mine is Chapter 8, which is pretty cool. Some of the other things I've done, the Southeast Valley.NET user group, I was presenting in LA and they said, that's kind of by Hollywood, right? This is the Southeast Valley.NET user group in Phoenix, so we meet in Chandler at Gangplank, which is really cool. So enough about me. We're here to learn about Kubernetes. No, we're here to learn about database DevOps. And in particular, database DevOps with containers. We learned about this guy. So the goals of DevOps, we're after reliability, consistency, cost. You know, in effect, our goal is to automate all the things. Anything that we do in a repetitive way, we want to automate that. So with apps, we're really good at building out these DevOps pipelines. With databases, things get a little weirder. Why do we automate all the things? Because computers are cheaper than people. That wasn't always the case, but that is the case today. So let's look at a typical DevOps pipeline. Here's a DevOps pipeline for apps. We start with checking out the code. We'll then, we start with a customer suggestion. We'll check out the code. We'll build some stuff. Ultimately, we'll commit that code to source control. The build server will kick off. We'll run unit tests on the build server. If all of those pass, we'll deploy that. QA will take a look at that QA server, and if they give us the thumbs up, then we can move that into production, and ultimately we get customer feedback. We start with customer suggestions, and we end with customer feedback. Customers really bound that process, which is really elegant, and that kind of defines our workflow through all these processes. Well, what's really cool about this is if, for example, the tests fail, we'll stop that cycle right there, and we'll loop back and start again. So in any of these processes, we can stop, and we can use that feedback to get better in the next iteration. And this could happen in any of the cases. Perhaps our build fails, or perhaps QA gives us a concern. Ideally, we talk about shifting left, moving feedback this way. If we can get feedback closer to when we write the feature, then that's good. So shift left. Well, how does this, where is the master copy in this process? If we were to lose everything else, what would be okay? The code. Yes. This source code repository. That's the critical piece. Given that, we can rebuild the rest of this. We can rebuild our application. We can run all of our unit tests again. We can get our app running back in production. The master copy here for applications is in code. So let's flip this on our head and talk about databases. Where's the master copy with databases? Is it still here in the source control system? No, it's not. It's here in production. The master copy of our stuff for data is production. For some reason, customers get a little bit grumpy when we just kind of like push the data out of the database and just throw it away and start over. Here's our master copy. We start with production. So when we create a database DevOps pipeline, we'll look at production, and we'll look at moving our data left into the environments that need it. So we'll take our production data, and we'll move it into a pre-prod thing where we can stage the next version of the application. Or we'll move it into dev test, where we can now start to flex it in really interesting ways. Or ultimately, developers may choose to have this data running locally so that they can iterate really quickly. So I have this DevOps pipeline, and if I have this short loop, this is called production backups. And so the simplest thing, we'll have no changes in our data store at all as we do this. Nightly, we'll back up our data, and if anything happens, we'll restore it. Or hopefully, we'll back up continuously, and we'll be able to restore to a point in time. If we go to the next level, well, if we're going to pre-prod, probably we're not mutating our data in any way. We're just kind of getting it into pre-prod, and then we can flex our application. Well, we've got this really grumpy developer who wants his database now. Remember that guy who he just needs that feature, and I'm like, get me off the phone. I'm working on this is why we want to automate all the things. Because that guy needs his data now, and I don't want to futz with it. So we've got our data in pre-prod. As we're moving into these other environments, we'll do additional things. We need to shrink our database, perhaps. We need to anonymize the data to protect it from PCI or HIPAA concerns. And we'll probably also want to sanitize it so that we don't accidentally email all our customers as we're running the tests. So as we're moving this way, then we'll anonymize it and shrink it and sanitize it more. So we get to the dev test environment, and so probably we're sanitizing a whole lot. We may not shrink very much. And then ultimately, we can get to this developer, and we can give him a copy of the database. Well, now I need to teach him how to install SQL Server and how to configure the database and what backup means and why he has to move the files. And that can get kind of involved. So oftentimes we'll say, OK, you don't get your own copy of the database. You all have to use this shared copy. So imagine you fire up your IDE. Is this WebStorm? Is this Visual Studio? And then ultimately, you go to that shared folder on the network server, and you open up your IDE into that shared folder, and you start coding away. And I open up the shared folder, and I open up my IDE. Perhaps I use Visual Studio. And I open up that code in that same shared folder. Do you see any concerns here? We're going to hit conflicts almost immediately because we're using the same files. We're going to hit conflicts in dev because we're using the same database. Let's empower developers to be able to create this sandbox area where they can burn it down at a moment's notice and get back to going really quickly. That's what we seek to automate. So at each step, we're going to anonymize, we're going to sanitize, we're going to shrink. Playing with photographers is fun. And then ultimately, we'll migrate it to the latest version. Do it again? That is so 80s. Anonymize, sanitize, and shrink. And then in each environment, we'll upgrade that to the latest version. Try out our production deployment. What's really cool, if we've done all of our migrations here, and we've done all of our migrations here, we're practicing a production deployment, and we've done all of our migrations here, we're not going to be surprised when we hit production because we've run these same scripts or these same processes a dozen or 24 times already. This is wonderful. And then ultimately, let's validate that this database works. So here's my proposal. We can do this automation process with containers. How can we automate this? With Docker containers. Docker containers will give us those tools to be able to get data from production into our other environments in a very hands-off way. So a moment about Docker. Probably we're a little bit more familiar with Docker, but Docker is a great way to build machines in a very automated way. I have configuration as code, and I'm able to fling that content into a Docker container in a really elegant way. Sometimes we look at Docker and we're like, isn't this like VM++? Yeah, it is, but it isn't. Docker is this mechanism of kernel virtualization, operating system virtualization. I think we're almost past this slide. Here's our traditional virtualization environment where I have my machine, and then I have my operating system. Maybe this is Ubuntu or Red Hat. And then I'll have my hypervisor. Maybe this is Zen or VMware. And then I'll install virtual machines into this hypervisor. And in each virtual machine, I will install the operating system, and then my dependencies, and then ultimately my application. Next virtual machine, I'll install another operating system. In Docker, because we're virtualizing the operating system instead of the hardware, I'll start with that same server. I'll install my host OS. Maybe this is Ubuntu. Maybe this is Red Hat. And for my hypervisor, I'll install the Docker hypervisor. Now, I'm virtualizing this operating system, so I don't need a copy of this operating system in each container. Instead, I just have my application and its dependencies. The difference between this host OS and these containers. So I just grabbed these containers, and automatically we see that we're in a much denser server utilization, which is wonderful. So Linux containers need to run on a Linux host. And Windows Server containers need to run on a Windows Server host because we're sharing that operating system, that kernel. What's missing? What? Do we have Red Hat and Ubuntu? We're virtualizing the Linux kernel, and Red Hat sits on top of the Linux kernel, and Ubuntu sits on top of the Linux kernel. So I can run Red Hat Docker containers on Ubuntu hosts. What else is missing? Wait, I'm running Docker for Mac. You telling me I can't do that? We only have Linux and Windows options? Well, probably locally we'll do something like this. In production, we want to go here because this is the densest utilization, and we've seen how we're running on top of the same OS that we need. In development, I'll have my Mac laptop. I'll have Mac OS. I'll use my native hypervisor. In the case of Mac, it's Xhive. In the case of Windows, it's Hyper-V. And then we'll install a Linux virtual machine. And into that Linux virtual machine, we'll install the Docker hypervisor. And then we'll run our Linux containers in there. With this mechanism, I'm able, from my Mac, to run Linux containers. Or from my Windows desktop PC, to run Linux containers. So now what's really cool, when I install Docker for Mac or Docker for Windows, it gives me this virtual machine by default. And that's wonderful. That's just built in, and it automatically proxies things back and forth. I could also choose to use Minikube, which is a tool by Google that gives us a single node cluster that I can do interesting things with. Any questions on Docker so far? So the Docker ecosystem, we have this configuration as code mechanism. We start with this Docker file, and in this Docker file is all of the steps that I need to be able to build out my machine. The Docker file will get built into a Docker image. I'll be able to share that image with others using Docker Hub. I can push content up to Docker Hub, or I can pull down images from Docker Hub. And then that image will get run as a container on the Docker hypervisor. So here's an image, and here's a container. Here's my DLL. Here's the instance running on my web server. So we can do this with one container. We can also do this with many containers in concert, which is really cool. So I'll have a Docker Compose file, and ultimately I'll run it in Docker Swarm or Kubernetes. So that's kind of the Docker ecosystem. So developers build these images. And so here's a Docker file, an example Docker file for an ASP.NET application. We have steps about copying in my manifest and running my package restore. We have steps for doing a build and a publish. And then ultimately, we have steps for launching my web server here inside this container. Now, devs are already familiar with this. Can we use these same tools in databases? Oh, Docker Hub. This is really fun. Turtles all the way down. So what's in that image? Well, what's in that image is this step, and this step, and this step. And if we had a minute, I'd pull up the Docker Hub for each of these things. And inside that image it uses a different base image that pulls it all the way down. So for example, this one said from Microsoft/.NET version 2.1. So that one will have, my container has these steps, and that container has these steps, and it's built on another default image that has some more steps. Then at runtime, we add this read-write layer per container at the very top. So now I can write things to all the places on my drive, and I can pretend this is a real machine. That read-write layer is magic because that's per container. If I launch 2 instances of this container, they all use the same all of this stuff, but they have their own read-write container. On the upside, every time I fire up my container, I have a new system. So hack me. I'll take that down, I'll start up a new container, and I'll have another brand new read-write layer. The downside is if I store my data there, customers get a little grumpy when we delete our data. So the Docker magic is about spinning up hardware fast. We get a brand new machine that has all of the pieces built in. I love this concept. As a developer, I think of this as a machine. I have all of the content. I can decorate my container. I can put up curtains. I can arrange my config files just so. And then I close the door on the container. And this container then gets handed over to ops, where they use standard cranes to lift up the containers based on these holes punched in their correct places. And so ops will plug in Ethernet, and they'll plug in power. They may constrain it to certain resources or spread it across availability zones. And they deal with this container as a process. Developers deal with it as a machine. Operations deals with it as a process. Even better, they're using the same tools. You know that 10-page Word document that gives you all of the steps to deploy? Except for we don't do step 7 anymore. And sorry, you need extra permissions to do step 13. We have a common language now between dev and ops. So I can pull down base images for like .NET and Node and PHP, and I can start to build out these containers as a developer. Towards the database realm, we can also pull down images for Redis or PHPMyAdmin or WordPress or Postgres. Or in this case, we're going to use SQL Server. SQL Server running on Linux is binary compatible with the SQL Server engine running on Windows. So by leveraging the SQL Server engine on Linux to do this automation piece, we can then hand our developers an image that has the database baked into it. Now in production, you definitely want to use virtual machines. In time, we may look at containers. If you're in the cloud, you definitely, in production, want to use database as a service. Let Azure or AWS manage your database backups. But in dev and test, can we create this database in a container? What we want is a dev-friendly thing with last night's production backup, anonymize, sanitize, and shrink this content, and ultimately we want this to be automated. So let's dig into this. I have here a file, close folder. here is a database. And I've got a few tables here. Here's a customer table, and it has quite a few fields with interesting content in it. And I have a settings table, and here in the settings table, I have some interesting content in it. In particular, notice here, it has the production secret. I really don't want that production secret to leak out of production. I want developers to be able to do what they're going to do. We also have another key in the settings table called the build date. We'll be able to watch that to see our application evolve. So I have this database, and step one in this process is I'm going to back up this database. Or I'm going to lock up SQL Server. Yeah, it's going to be really grumpy. No, I really don't want to save that. OK. So let's back up our database. We want to do this all the time anyway. And so perhaps we're already leveraging our production database backup. Now, in this case, this database was kind of small, so that worked really quickly. But now I have this prod database.back file. That's perfect. Let's start there. So I've built this Docker file here. And this Docker file will do some interesting things. So we have to accept the EULA. And let's set an SA password so that the SA password is different for development than production. Now developers can't accidentally connect to production and do bad things. We'll start with Microsoft SQL Server Linux, and we'll call this a build image. And then we'll copy that production database backup into our temp folder. We'll copy the SQL file into the temp folder, and then we're going to run SQL Server in the container. This is one end, so it will sleep for a bit while it's starting up the container. And then two ends, so it'll wait until those are done. Two ends will run this SQL command connecting to that local database, passing in the username and password, and then running that production, or that prod to dev SQL script. And then ultimately, we're going to kill SQL Server. That SQL script is right here, and that will do some interesting things. We want to do the sanitize and anonymize and shrink processes. So the first thing is we'll restore our database, and we need to move it because it's no longer in C:/SQL Server. It's now in var opt MS SQL data. So we'll move our content to where we expect. Let's sanitize the data. We'll set all of their emails to a new ID at contoso.com so we don't accidentally email our actual customers in this process. We'll update our settings key to a dev safe value. And then we'll set our build date just so that we know what time we built this. That'll be really interesting to watch. Let's shrink the data size. So in this case, we're going to delete content from the invoice log. And in this case, I love this where clause. So we're actually not doing it very much at all. We'll then truncate our log file and shrink our database and database file. Solving orphaned users. As we're moving databases to other servers, we may have logins that don't quite gel, so we'll just go double check that. So that's our prod to dev script. And this script may be modified in different environments to cater to different things. As we're going to pre-prod, we'll probably do much less. As we're going to a developer's workstation, we may do even more. Let's shrink further. So this Docker file will build all of that content, run that SQL script, and get us to the right place. And then we're going to use a multi-stage build here to start a new container called dev. So now we don't have the production database in our temp folder anymore. This is a second container. And we're just going to copy from build, so copy from that other container. We're going to copy that into this new image in the same place. We now have this image that has all of the Docker content and all of the production data here in our container. So let's go do that. Docker build right there. So I'm going to get into that database directory. And then I will do that Docker build. Now it's going to do this. It's going to sleep. I have to guess how long it'll take SQL Server to spin up. But it will go copy that content into the container. It'll go anonymize, sanitize, and shrink that data. Here's SQL Server starting up. That is wonderful. Upgrading the database. So get it to the latest version. We could also run migration scripts as well. We're waiting for the rest of the 60 seconds. The hard part of this demo is, sometimes it spins up in 10 seconds, sometimes it spins up in 90 seconds. And so it's like, how little can I wait before I know that it's good? I would love if SQL Server had an event that said, OK, I'm ready, time to do the next part. Thank you. I thought that was pretty awesome, too. Yeah, the clapping in the other room was pretty cool. OK, so now we're starting to run our script. We updated our production database, our web app database. We did all of the other modifications. And now we're done with our SQL script, and we finished building out this container. Docker image list. Here is our dev database. Our dev database container now has all of the production content from last night's backup, anonymized, sanitized, and shrunk, and ready for developers. A developer then in the morning can just say, Docker pull dev database. They don't need to install SQL Server. They don't need to configure the database. Or they can wait until they're ready. So now let's run that database. And I'm going to grab the Minikube IP before I do so. There we go. And so let's run that dev database. I've now started up that database. Let's connect to that database. And here in this database, let's look at this. Oh, I'm in the master database. Let's switch to the production database. Did I spell settings wrong? Oh, I'm in tempdb. Thank you. Web app database. And here we go. I now have my dev-safe content, and I know what date this was built. Your production database is only as good as the last time you restored it, and we restored it in a very automated way every day. We do this process of anonymizing, sanitizing, and shrinking our data, and making it available to our developers in a very, very productive and automated way. So SQL Server on Windows and Linux is pretty much binary compatible. We didn't do anything with our database backup to say, no, move it to Linux mode. But on Linux, we don't have reporting services or analysis services. And if that's a deal breaker for you, this isn't a great technique. But ultimately, we did this automatically. There was nothing all that intense and hard about this process. Here's my pitch. Just go do it. Thanks for coming.